Have you ever been in a situation when your software testing or software development team does great job testing the software, maybe puts a lot of effort in it, but in the end you still get a very poor result with low quality, a lot of outstanding bugs and unhappy customers? Well, I've been in situations like this many times, and in this video I want to share my top 5 reasons why traditional software testing approach might lead to the situation like this. And also in the end of the video I will give you a quick overview of a potential solution that we use in our company. Hi everyone, and welcome to my new YouTube channel QA with Andrei. My name is Andrei and I am a principal quality engineer at Atlassian. At Atlassian we use a quite unique, maybe not so unique these days, quality model called quality assistance, which is different from the traditional testing approach. So I decided to shoot a series of videos describing how do we do testing at Atlassian. This is the first video in this series where I want to share my opinion about top 5 problems with traditional testing approach. To begin with, let's define what the traditional testing approach is. Well, different people might define it differently, but for the purpose of this video, let's decide that the traditional testing approach is a model when we start testing only after the development is finished. And also, the testing is done by a separate group of people requiring a separate expertise, software testers, while development is done by developers with the development expertise. This approach is also often called shift right, because if you look at the project timeline, going from the left to right with different phases like requirements, design, development, and then testing, the majority of investments in quality are happening during the latest stages of the project, namely during the testing phase. And they are heavily shifted to the right. That's why the approach is called shift right. So the question you might have is, what is wrong with this approach? We've been doing it for many years, actually for decades, and everything was okay. So let me tell you, there are problems. Problem number 1, you won't be able to release high quality product to your customers after testing if the product in the beginning of testing is bad. There is a rule in the electronic engineering: garbage in, garbage out. If you have a component which takes a signal as an input and produces an enhanced signal as an output, no matter how good component is, if your input signal is faulty, you will always get garbage as an output. The same with testing. Testing and bug fixing doesn't make your product better. If requirements in your product are badly defined or not defined at all, if your product design is not clearly defined, if your team doesn't follow engineering excellence rules and they don't create any automated tests or anything, and the code is bad, no matter what you do during the testing and bug fixing phase, you will end up with a faulty product in the end. The testing and bug fixing might look the product better, but you will still have a lot of non-functional problems, you will have maintainability issues, and a very high risk of uncovering a defect in production. Problem number 2 is imbalanced quality responsibilities. Because a software testing team is usually a gatekeeper for a product, for a feature, or for iteration, they are believed to be responsible for quality. What happens if something goes wrong in production? Then everyone will go back and they will reevaluate testing. They will ask questions like, why didn't we test it more thoroughly? Why didn't we have more tests? Why didn't you test better? Are you even qualified to do testing? But no one ever asked like, maybe something was wrong with development. Maybe we should have created some unit tests, or maybe we should have defined our requirements better. In most cases, we will look at software testing engineers as something that we want to improve. What happens is that developers in this situation rely too much on software testing engineers, and they don't have incentives to produce high quality code, write automated tests. Moreover, what oftentimes management will rely on testing, and they will give developers less time to produce high quality code, thinking that after testing all the problem will be gone. But that's not the case. As a result of all this, if something bad happens in production, if the quality is not satisfactory, the team will mostly invest in adding more testing, but not in solving the root cause problems, which are low quality code. Problem number 3 is that traditional testing model is not agile in its nature. It was designed many years ago when everyone was doing waterfall software development, and when we try to apply it to the agile world, it simply doesn't match. If we look at the agile manifesto, it says that the success criteria is shipping working software frequently. It doesn't happen with traditional testing model, because your software is not working until you finish all the testing and all the bug fixing, so you don't know if you are successful or not. Also, Agile Manifesto tells that the engineering team must prioritize engineering excellence. Again, usually it doesn't happen in the traditional testing model simply because developers are not given enough time and incentives to invest in engineering excellence. Problem number 4 is a very low predictability of software testing phase. What do I mean? If you look at software testing books, you will find that there is such a thing as a smoke test, which essentially is a very basic test that verifies major features, and if the smoke test passes, then we consider that the product is ready for testing. That looks logical. However, let me tell you something. There might be two same products designed by different teams. One of them can be very healthy with very few bugs, and another can be completely broken but with main features working. It might have a lot of minor and medium bugs, a lot of regression or flackiness, something like this. Both products will pass smoke test without problems. But what happens during the testing? The first one will be tested very quickly without any bug fixing. The second one might take months to fix, and maybe it's not possible to get it working because of a lot of regression. And you never know what's going to happen until you are in the middle of your testing. And the problem is getting even worse when the testing phase gets squeezed because the development phase takes longer, and usually if there are quality problems, then development phase is always delayed and testers need to scramble to get the testing done, and usually that leads to compromising quality, leaving a lot of unfixed bugs in the backlog, accepting them and maybe not running all the tests, and as a result a low quality product. Problem number 5, and the last problem in this video, is that the traditional testing is not cost effective. What do I mean? If you look at the cost of fixing a defect over time, you will see that it grows exponentially while your project progresses. There is a research done by IBM or some other company, I don't remember exactly which one, but it says that fixing a defect during the testing phase is 10 times more expensive than fixing it during the development phase. Also, fixing a defect during the production phase is 100 times more expensive than fixing it during the development phase. And it does make perfect sense to me, because if you are fixing a defect when you just write the code, it's easy. You can write a unit test, spend 1 hour and prevent a defect from happening. However, after a month or so, you will need to find where this defect occurred. You need to understand the code, talk probably to other people, and sometimes it's not even easy to fix because maybe other people built on top of the faulty software and you need to change the architecture. So having said that, you want to find your bugs as early as possible because you will have a very low fixing cost. Whilst if you invest in the end of the process in your quality, then you will find your bugs later and you pay much more money to fix those bugs. Okay, I hope by now you are convinced that the traditional testing approach is not optimal and you have to try something else. You might ask me, okay, Andrew, what's the alternative? And let me tell you, the alternative is a shift-left approach. It's the approach that we're heavily using at Atlassian, and the idea of this approach is that we start investing in quality as early as possible in the beginning of the project or a feature or an iteration. We are trying to be proactive and prevent defects rather than wait until we find them and fix them. We are relying on development team to build all needed test tooling to create a high quality feature without a need to test in the end. And the quality engineer role, which is me, is to make sure that this process is maintained and is evolving to guarantee that we create better and better products. That's almost everything I wanted to share in my very quick video today. I didn't want to go into too much details on how we test at Atlassian, how our quality model is built, because I want to shoot more videos about this in the future. If you are interested, please subscribe to my channel and stay tuned. Also, finally, I have a bit of a homework for you. I challenge you to look into your current project and leave in comments if you see any problems that I mentioned, and also try to evaluate whether you are doing shift left or shift right or something in the middle. That's it for today. Thanks for watching and bye bye.